What if I told you that the technology behind ChatGPT, Google Translate, and BERT all share the same revolutionary architecture? Welcome back to the channel. Today, we're diving deep into one of the most groundbreaking innovations in AI, transformers. This is AI Academy, and in the next 10 minutes, you'll understand how transformers completely changed the game in machine learning. We'll break down complex concepts into simple, digestible pieces with real examples you can relate to. Here's what we'll cover today. We'll start with why transformers were needed, explore their core concepts like self-attention, dive into their architecture, see real-world examples, and discover their amazing applications. So grab your coffee, hit that subscribe button, and let's transform your understanding of AI. Before transformers, we had RNNs and LSTMs for sequence processing. But here's the problem. Imagine trying to remember the beginning of this sentence while I'm speaking these words right now. That's exactly what RNNs struggled with. RNNs process words one by one, sequentially. By the time they reach the end of a long sentence, they've forgotten what happened at the beginning. It's like having short-term memory loss. Transformers solved this with a genius idea. Instead of processing words one after another, they look at all words at once. It's like having a bird's-eye view of the entire sentence. This parallel processing made them faster and better at understanding context. The results? Transformers achieved state-of-the-art performance on translation tasks, with blue scores jumping from 28 to 41 on English-German translation. That's a massive improvement. Self-attention mechanism. Let's start with the star of the show, self-attention. Think of it like a spotlight in the theater that can focus on multiple actors simultaneously. Consider this sentence. The cat sat on the mat. When processing the word sat, self-attention helps the model understand that sat is strongly related to cat, who is sitting, and mat, where the sitting happens. The math behind it? Attention, QKV, equals softmax, QKT, divided by square root of DK. Don't worry about the formula. Just remember that Q stands for query, what am I looking for, K for key, what information is available, and V for value, the actual information. Here's what attention looks like in action. Darker colors show stronger connections between words. See how river and bank light up together? That's attention working. Positional encoding. Here's a problem. If we process all words simultaneously, how does the model know word order? Dog bites man versus man bites dog. Very different meanings. Transformers use positional encoding, mathematical patterns added to word embeddings. Think of it like giving each word a unique address in the sentence. Position 1 gets one pattern, position 2 another, and so on. The encoding uses sine and cosine functions to create unique fingerprints for each position. This way, the model always knows where each word sits in the sequence. Multi-head attention. Single attention is good, but multi-head attention is brilliant. It's like having multiple experts analyze the same sentence from different angles. Imagine 8 different people reading the sentence, "The bank by the river." One expert focuses on financial context, another on geographical context. Each head captures different relationships. These different perspectives are then combined to create a richer understanding. It's like getting multiple opinions before making a decision. Feed-forward networks. After attention, each word goes through a position-wise feed-forward network. Think of it as individual processing units for each word. It's a simple 2-layer neural network, input, ReLU activation, output. This adds nonlinearity and helps the model learn complex patterns. Pro tip, transformers use residual connections. They add the input to the output. This helps information flow better through deep networks, like creating shortcuts in a maze. Now let's see how all pieces fit together. The original transformer has 2 main parts, encoder and decoder. The encoder, the left side, processes the input sequence. It has 6 identical layers, each containing multi-head attention and feed-forward networks. Think of it as understanding the input deeply. The decoder, the right side, generates the output sequence. It's similar to the encoder but has an extra attention layer that looks at the encoder's output. Let's trace through an example, translating Hello World to French. The encoder processes Hello World, creating rich representations. Then the decoder generates Bonjour Monde, word by word, using both the encoder's understanding and previously generated words. The magic happens in cross-attention. The decoder attends to relevant parts of the input while generating each output word. It's like constantly referring back to the source while translating.
Let me give you a real-world analogy. Imagine you're at a busy restaurant with multiple conversations happening simultaneously. Your brain uses attention to focus on your friend's voice while filtering out background noise. You can also quickly shift attention when you hear your name mentioned at another table. That's exactly what self-attention does. In document analysis, when processing, the company's revenue increased significantly. Attention helps connect revenue with increased and significantly, understanding the complete context even if they're far apart. This simple code shows attention in action, computing relevance scores, converting to probabilities, and creating weighted outputs. Transformers revolutionized multiple domains. Let's explore the key applications. In NLP, BERT revolutionized language understanding. GPT models generate human-like text, and T5 handles multiple tasks with one model. Google Search uses BERT to understand your queries better. Vision Transformer, VIT, treats images as sequences of patches. Instead of convolutions, it uses attention to understand spatial relationships. Results: state-of-the-art image classification. Multimodal AI, models like Clip understand both text and images. You can search images using text descriptions, like "show me photos of cats wearing hats," and it works. Beyond text, transformers excel in time series forecasting, protein structure prediction, AlphaFold, and even game playing, like in reinforcement learning. Let's look at the incredible journey. 2017, original transformer paper. 2018, BERT changes NLP forever. 2019, GPT-2 shows massive scale potential. 2020, GPT-3 amazes the world. 2022, ChatGPT goes viral. And 2023, GPT-4 sets new benchmarks. The numbers are staggering. GPT-3 has 175 billion parameters, while GPT-4 pushes boundaries even further. Model sizes have grown exponentially, but so has their capability. Current research focuses on efficiency, making transformers faster and smaller. Techniques like pruning, quantization, and distillation help deploy these models on mobile devices. What's next? We're seeing longer context windows, better reasoning capabilities, and more efficient architectures. The future of AI is being written with transformers. Let's recap what we've learned today. Transformers use self-attention to process sequences in parallel, making them faster and more effective than RNNs. The encoder-decoder architecture with multi-head attention creates powerful models for various tasks. The impact is undeniable, from powering ChatGPT to revolutionizing Google search. Transformers are the backbone of modern AI. They've democratized access to powerful language models and opened new possibilities across industries. Want to dive deeper? I've linked the original Attention is All You Need paper in the description, along with interactive tutorials and code examples. The Hugging Face Transformers library is perfect for hands-on experimentation. If this video helped you understand Transformers, smash that like button and subscribe for more AI deep dives. Drop a comment telling me which part fascinated you most. Should I create a follow-up video on implementing Transformers from scratch? Next week, we're exploring how to fine-tune BERT for your specific tasks. You won't want to miss it. Thanks for watching, and remember, the future is transformed by those who understand Transformers.